Hello, welcome to a quick little R video on how to compare the centers of many samples. 2 videos ago we were drawing conclusions about the mean of a single sample. Last video we were comparing the means of 2 samples. Here we're taking it to that next step. We're looking at more than 2 samples. The steps really are the same. We're asking what is the parametric test. We want to use the parametric test. It's a more powerful test. What are the assumptions of that parametric test? Do the data violate the assumptions? If they do, then we have to use the non-parametric test. If the data do not violate the assumptions, we get to use that parametric test. Have a benefit of some extra power. Situation hasn't changed. School zones still have reduced speed limits, even when children are not present. In Stillwater, that speed still is 30 miles per hour. Question has changed. 2 questions ago, we were trying to figure out what the average speed was. Last time we were comparing the average speed in Zone A with Zone B. Here we're asking, does the average speed that cars travel differ at all among the 4 school zones? Which brings us to the hypothesis. The research hypothesis almost always is that the average in Zone A is equal to the average in Zone B, is equal to the average in Zone C, is equal to the average in Zone D. Because it's got all those equals, that's also going to be the null hypothesis. The alternative hypothesis is that either mu A doesn't equal mu B, or mu A doesn't equal mu C, or mu A doesn't equal mu D, or mu B doesn't equal mu C, or mu B doesn't equal mu D, or mu C doesn't equal mu D. I think that was 6 possibilities. Or we could just write out at least one mean differs from the other. So the null hypothesis is that they're all equal. The opposite of all equal is that at least one is not. So here's the test. The parametric test is called the analysis of variance test. The assumptions, one of those we've been seeing a lot, is the normality in each of the groups, that the data in each of the groups is generated from a normal population. We do have a second assumption, though. That second assumption is that the groups, the populations, have equal variances. Again, to test normality, we'll use the Shapiro-Wilk test. To test equal variances, we're going to use something called the Fligner-Killeen test. If it passes all of those tests, then we get to use analysis of variance. If it fails any of them, for now we'll just use the Kruskal-Wallis test. Kruskal-Wallis test is the non-parametric analog of the analysis of variance test. So let's see how this works. Again, we've read in the data, we've attached it, we've got our summary. We want to compare if all the means are equal. We'd like to use the analysis of variance test. Unfortunately, the analysis of variance test has 2 assumptions. One, that it's normal in each of the groups, and 2, that the variances are equal. Let's go ahead and test the variances first. Fligner.test. Fligner.test is the R code to run the Fligner-Killeen test. Fligner.test usually requires the measurement variable, a tilde, and the grouping variable. However, here we just have 4 variables. So we're going to have to combine these 4 variables. Here's the easiest way of doing it. List Zone A, Zone B, Zone C, Zone D. And that's it. P-value is 9.842 times 10 to the negative 5th. Because the p-value is less than alpha, we reject the null hypothesis. The null hypothesis here is homogeneity of variances. In other words, that the variances are equal. Since p is less than alpha, we know the variances are not equal. Therefore, we cannot use the analysis of variance test. Therefore, we must use the Kruskal-Wallis test. As you may guess, Kruskal-Wallis test in R is implemented in using Kruskal.test. And again, Kruskal.test usually expects the measurement variable, a tilde, and the grouping variable, But since we actually have 4 variables that we're comparing with no grouping variable, we got to hold everything into a list. And here's the results. P-value is 1.607 times 10 to the negative 15th. Therefore, we reject the null hypothesis. P is less than alpha. We reject the null hypothesis. Kruskal-Wallis test was testing if the means were all equal. We reject the null hypothesis of the equality of means. Therefore, we conclude that at least one is different from the others. So at one level, we're kind of done here. We've answered our question. No, the average speed that cars travel does differ among the 4 school zones. But really, it'd be interesting to know which one is different. Well, that will have to wait for the next video. But now let's do a box plot. So there's the box plot for the 4 variables. Probably should include a names slot. Looking at this, we can probably guess that zone D is the one that's different. We have not statistically shown that zone D is the different one. It may not be the different one. But looking at the box plot, it would not surprise us that when we actually run the next test, we actually do see that zone D is significantly higher than the other 3. But that will have to wait for the next video. This video is all about using the analysis of variance test or the Kruskal-Wallis test to determine if the means of 4 groups were the same. We decided they were not. So again, parametric test was the analysis of variance. That was the one we chose because we were trying to test equality of multiple means. Technically, it works for the equality of 2 means, but we have the t-test for that, and it's a little bit better. Has 2 assumptions, normality in each of the group, and equality of variances. And that's equal variances of the populations. And it's normality of the populations for each group. The assumption test are the Shapiro-Wilk test and the Fligner-Killeen test. Again, Shapiro-Wilk test tests the normality assumption. Fligner-Killeen tests the homogeneity of variances assumption. If any of that fails, we'll use the Kruskal-Wallis test. If all of them pass, we get to use the analysis of variance test. So hopefully this was helpful. Wait for the next video to find out which of those speed zones has the fastest drivers on average. Bye.